system. That's why the question has disappeared. The participant, the question was like this, that why? Because the authentication is much more better here. Does it something to do with the technology or some modulation scheme like that?
It's a very technical question. Whether the augmentation system works better here, you mean in India? Honestly, I can't answer this question. If you formulate it in writing, or the person puts it again, we'll certainly get it answered and play it back to you from the Galileo Service Center. Yeah, sorry, I can't help you here. So, introducing the value-add services of Galileo.
Just 1 minute. We cannot see your presentation. We can see the blank. I can only see the your screen. So I think you just stop presentation and once again represent it.
Can you see it now? Amandia, can you see my screen now?
Yes. Now, yes. Okay. Now, yes. I was waiting. Now, yes.
Okay, here we go. So, the Galileo differentiators, the value-add services of Galileo, one by one. Let's start again at the bottom with the Open Service Navigation Message Authentication. This provides higher service robustness, and it will help providing information about the fact that it's an original signal. It's not a faked signal, so spoofing will be not possible with that. Yeah? It will eventually be complemented with a commercial authentication service that will provide access to encrypted E6C codes. So the OSNMA is only the starting point. If you then look on the right-hand side, the high accuracy service, it's reducing positioning errors, and it will practically be a broadcast service coming through Galileo from the satellites. You will get free PPP service. A bit similar, I guess, to some functionality that was introduced earlier by the QSSS speaker by Dinesh. On the left-hand side, we've got the emergency warnings service, which is using a short messaging services. It transmits alerts to smartphones, so short transmissions like earthquake suspected, or something like a tsunami, or power outage, or something like that, flooding, whatever. Those kind of things will possibly be communicated with phones in future generations. We hear that some mobile phone operators are already working on implementing it. Certainly, there are the first chipsets being built that can support that. The search and rescue service is mainly meant for people in either remote areas or more so men overboard in maritime context, so that there is a return link notifying the person in trouble that the signal has been received and help is underway. So, in more technical terms, what are the different types of errors that there are in receiving a GNSS signal? And obviously, there are different means to try to do something about it. Yeah? Ionospheric effects are largely trying to filter out through S-bus systems as complementary systems, or with multi-frequency. Also, multipath with reflections and so forth can be removed for some of this. Yeah? Clock errors, etc., etc. There are other topics. If you're interested in the detail of this and these type of effects and how the Galileo system is addressing with various add-ons and special features and which services eradicate which error, have a look at the Galileo Service Center GSC-Europe website. So A bit more detail on the high accuracy service, which is effectively a PPP service from the sky, using the correction data and bringing it to the receiver, or alternatively delivering it through the internet so that you can ammunition your receiver with the right correction data. I would assume that the audience is familiar with the concept of PPP. Here are some quantitative KPIs that the system aims to achieve. There's eventually going to be a global service, but initially Europe is going to start with a coverage with a guaranteed service across Europe, the European coverage area, which is slightly bigger than Europe and the European Union because of some outer islands. So you see here the respective parameters, how they play out. The main difference is in the convergence time. Here's the rollout plan for the high accuracy service. We're going to have 3 phases: initial testing and experimentation, which will be starting in the next months. Already activities are underway to support that with communication and user tests, and those tests will then be made largely public so that the interested community knows about it. Followed then by initial service and eventually a full service declaration when the global service is available. You can be assured through GNSS Asia, you will be notified of any progress in this dimension. We'll cover it in newsletters, in special features, and even more so when it gets relevant for your geographic region. Next, the Galileo Search and Rescue service, helping to save lives. Yeah? Typically, let's take the example, somebody goes overboard, the ship travels on, the person gets some drift because of currents and so forth. It typically takes a long time, up to 4 hours, in a radius of 10 kilometers to search the person in a helicopter. So in very cold waters of open sea, 4 hours is mostly deadly because people will not survive that stress on their body. However, this can be reduced to 10 minutes with correct localization and dynamic localization. There's a higher chance of finding the man or woman overboard in a state which makes him, which will allow him to survive that activity. So, and this is part of the COSPA SARSAT MEOSAR program, which provides some of the ground assets and space segment assets to make this communication service possible. So there's a little video. I think I'll try to give you a voiceover by myself. Let's do it like this. So obviously somebody is going through the woods in a very, and is out there possibly getting lost. And the ranger is probably trying to help him. Equally, it could apply to people being active sportsmen, sportswomen out on the lakes. Doesn't have to be open sea. The user is triggering a beacon and this signal is picked up. You see here the Program Manager of Galileo, Paul Flamand speaking. I will provide afterwards the link with all the videos of this presentation. So people getting injured, people falling overboard, whatever, as long as the person can still activate the SOS, he is in a chance of getting found. And some of these devices are very easy to use. They don't need to operate the touchscreen or something like that. It's just an emergency device, the specialty devices. Other devices operate with a smartphone. So help is underway on land, on the sea, or in inland waterway. The rescue squad gets the exact position of the person in distress. Reaching you faster, every minute matters. So, some calculations from typical rescue times you've seen before. So, let's make this a global system. Let's make sure this technology is getting introduced around the world for the benefit of everybody, and it's a contribution to people rescuing lives from the European Commission. So, this is how it works with all the beacons and all the systems interoperable here. Have a look at more details, and I'll certainly also share the presentation if that's something you would like to work on or conduct some specific research. Yeah? Or possibly find ways of integrating NAVIC solutions into this. So, next differentiator is the emergency warning system, which is helping to warn from man-made or natural disasters, flooding, storm, earthquakes, etc., etc. So various hazards can be broadcast on demand with an alert message, which arrives on your smartphone in an SMS text message-like style. The smartness about it is you can actually reduce the area of who should receive it to the people that are most likely affected, that you don't get false alarms or that you don't get people into panic, getting off their car and stopping in the middle of a motorway or whatever. Yeah? So the relevant population can be targeted by the means of an ellipse that the number of coordinates are defined and saying, okay, this ellipse is most likely to be affected for people, and that measures can be communicated or help that they might want to look up for guidance how to behave in a situation, even if it means switch on the radio. Again, this is how it works. Typically something that is triggered by the civil protection authorities, feeding national emergency centers. They are then informing Galileo and the system is put into the sky. The information is put on the sky and broadcast down to whoever is concerned with pointed functionality from the satellite. Then, of course, doing something about spoofing. Yeah? There are some areas around the world where it's close to impossible to do decent navigation with traditional GPS, because for security reasons, certain property is protected by spoofing or by intentional falsification to avoid any attacks or something like that. Yeah? So this is what could happen if you're in Moscow. Don't rely on your Google Maps or the functionality of your built-in GNSS of your smartphone. So in this case, the Open Service Message Authentication will give you a warning and say, sorry, the signal doesn't work, don't rely on it, and so forth. And it will work. Eventually, it will be improved with an even better service, which is the commercial authentication service. But for now, it is a smart solution. It has been built into the signal using some spare bits in the message structure and relatively easy to implement. Again, here, there's a clear roadmap. What's coming when? Internal testing is underway. Preparation for phase 1 is imminent, so stay tuned. Also, GNSS Asia will inform you when things are possible, and it might be actually an interesting feature to test with your students, with your research groups in the coming year. And we would certainly be very interested in Europe to hear about your experience with it. If you need more backing, more information about how to use it, what type of equipment you can use for that, the OISPA agency is certainly very interested in learning how the system behaves in other parts of the world. There's the public regulated service. I don't want to say much about it because it's not relevant for you. I would assume similar functionalities are available for NABIC for national interest and security purposes. So there's no access from your geography to this because it's all encrypted with high security standards. So I think we're done with the technical part of it. Are there any questions here and now already on India that we should possibly address?
Till now, there is no question. Only one question that you told that you will take it afterwards or try to get the answer. But still now, I would request all the participants, if you have any question, just type in your question so that I can pick those questions up and forward it to Mr. Horn for answering. Please. Okay, still now there is no question. You can proceed.
Okay, so now the technical part is done. We're looking more now at the market and what is happening in the GNSS market. You see here a few high-level facts from the recent Galileo market report. There's 2 billion smartphones enabled for Galileo right now. They're all using multi-frequency, multi-constellation chipsets. And so that is a great news. So most of the phones, also the ones very broadly used in India by now, should be more recent generation and should have some capability in this regard. Most of the car brands, most of the drones are using it. In maritime, the European GNSS system is part of a global standard. And we already have the first beacons introducing Galileo for search and rescue back in 2018. Yeah? And this goes across the transport modes. And the whole geomatics community is, of course, using Galileo. They're using whatever they can to get higher accuracy and having their augmentation systems building on a full set of constellations from around the world. In addition, there is a high number of satellites out in the sky that are navigating using GNSS, using GPS, using Galileo, whatever. There's even some first applications using the signal of Galileo indirectly for weather projection, the so-called weather prediction using GNSS, measuring vapor in the air, measuring clouds in the air, and thereby giving additional information to weather forecasting systems. Looks like this animation we don't really need. So now looking at the ecosystems that are being addressed by European Space Program Agency, it's in the order of what is relevant for Europe and what is helping to make European industry and society more digital, more modern, and more efficient. So here are a few examples: agri-food, digital, mobile transport, automotive, of course, energy-intensive industries, renewable energy, and construction. So we're going to show you a few examples from some of these ecosystems and how, in particular, GNSS is helping along that. So the application of Galileo is almost limitless. These are some of the segments that are addressed very actively by OISPA. There are specialist project managers and service managers who are very knowledgeable and extremely connected in the scene. So if you have a special event for the maritime industry, for the rail industry, for agriculture, etc., feel free to contact GNSS Asia so that we can tap that knowledge and help you giving specialist briefings about applications, challenges in those markets. So let's take the example of aviation. The European EGNOS, as I said, it's the equivalent of Gagan, has been introduced in over 300 airports. Now, this is helping to have the secondary airports that are not equipped with the latest automatic landing aids, having them being equipped and being upgraded. So it's a safety upgrade for secondary airports first and foremost. But also, EGNOS has been made ready and is used by the general and business aviation, business jets, small aircraft, even Cessnas that have an upgraded Garmin receiver in there using the patch that was developed for EGNOS. So overall, it adds to flight safety for approach, landing, and en route. So in the end, it's helping to correct some elements of the errors. That's the principle of any WAAS system. It's a global standard accepted by ICAO. And in the future, we expect that ICAO will also expect the WAAS systems to augment not only GPS, but also other systems such as Galileo. And that will certainly help big time the next step of flight safety. On the rail side, we see significant safety increases. Standards have been developed in Europe, the ERTMS standard, which we understand has already been implemented also in other parts of the world, in particular in Australia. We heard there are discussions about that for the novel rail lines built in India. And in particular, I understand in India, due to some very old system, there might be also less complicated systems in the railway area possible to avoid collisions, to avoid collision with passengers, to enable some warnings, train approaching, etc., etc. But ultimately, in rail, there are 5 or 6 applications, sub-applications that are actively followed and are being monitored. We also see that a variant of ERTMS is currently being rolled out in China. So there's another short little video for rail. Let me see how long it is. I'll try to give you a voiceover. Railway operators are increasingly using satellites for their operation. So the position and speed of the trains can be provided to different stakeholders in the railway ecosystem. So it's addressing the efficiency of the railways, the safety. Currently, there's expensive equipment required. These are the so-called balises. They can be replaced. They can be eliminated when GNSS is being used. So onboard systems based on satellite can overcome that. Cost of maintenance and investment can be reduced. The target is low density regional line. So I guess quite a lot of that we have in India. The fleet management, scheduling, and maintenance can also be improved with it. Tracking freight cars and optimize the planning for fleet. The real-time location of a train can then be communicated to passenger information systems. So modernizing both infrastructure, train vehicles, but also information for the passengers. So you got a bit of nice scenery of urban and not so urban areas of Europe. So again, the videos will be made available to you. Coming to maritime, let's go offshore. So there is all kind of work being happening also in this area, OISPA and the European institutions are actively working with stakeholders, institutional and industrial alike. As you could just see in the railway example, there's a constant dialogue with these people. What are their requirements? What can we help industry to adopt these things faster? And obviously constantly monitoring what are the applications, what are the key benefits for these activities. And again, here in the maritime area, it's between the vessels, the stations, the home bases, the harbors, and the fishermen, so they can use improved navigational aids. Collisions can be avoided, disasters can be mitigated, oil tankers are not colliding with other ships if there are warning systems, etc., etc. We have some of the biggest harbors in Europe, and right now they're probably not as busy as they were before Corona, but still there are quite a number of automation features possible using, in particular, Galileo, and making the loading and offloading more efficient. So feel free to have a look at our innovation blog from GNSS Asia. It's showing all kinds of areas of applications, here showcased in the context of an ASEAN workshop. And also there's a presentation and all kinds of videos around that event available for you on the website. If you want to do a deep dive with your students, with other faculty on maritime, there's all kinds of material you can use. Now, Europe also has another system that is freely available for the world and its products, the data of Copernicus, the Earth observation program made in Europe. Farmers are increasingly bringing all these technologies together. They're using GNSS for positioning of their tractors on the field and optimizing seeding, harvesting, and statistics around their productivity, but also Earth observation, drones, meteo data, and so forth. We do know you have a very diverse agricultural world in India, ranging from very small plots that are too small to be managed with machine-driven tractors, all the way to the latest and greatest highly industrialized farming activities in the northern parts of the subcontinent. So obviously you are dealing with a wide diversity of things, but in any type of digitization, these tools are suitable and differently suitable of different level of sophistication. In Europe, Japan, and North America, we're already talking about swarm and autonomous machinery, farming robots running operation autonomously over fields, helping with harvesting of various fruit types. In particular, in Europe, the integration of these two tools is being used to enable a new common agricultural policy. Europe has a subsidy scheme to keep farmers in business and to encourage certain crops to be planted and others not to be planted, to make sure Europe can feed itself. So this subsidy system, which of course needs some controls to avoid misuse and fraud, the control systems around that are in the future enabled by European space systems, Copernicus and Galileo. We in Space Tech partners, we have been working on piloting this for the European Space Program Agency highly successfully. Already 4 or 5 countries are using this application in practice. Yet another video. I will cut it short if it gets irrelevant, but you get a bit of a feeling what's going on, and you certainly will see nice landscapes and land here. We need to produce more food with limited amount of land for a growing population. So you can see what highly industrialized machinery is being used in some parts of Europe. So explaining how EGNOS and Galileo are working in the principle, I think we've had that. I'll fast forward a bit. Variable rate technology is to use fertilizers in a very intelligent way, using maps, not to put too much pesticide on a place where it's not needed, having better dosage of fertilizers, but also to map the moisture of different parts of the field to optimize watering and other treatment of the ground. So reducing the nitrogen costs, reducing the harm to the environment. Resource efficient use of agricultural resources and UAVs and drones are being mapped, are being assisted by EGNOS and Galileo to provide accurate images of fields and optimize the use of ingredients. Real-time accuracy for steering and overcoming driver fatigue. Optimizing the way to do business and having them focus on the critical task, not only steering wheel holding. So these trackers show how healthy an animal is, if there is an emerging disease of some sort before other animals catch the same disease. Some animals can be isolated, and you can also see where they are, where they've been grazing, in case there is a danger that comes from grazing. The trend to biofoods and so forth will want consumers to know where their food is from, if it's really biofood or if it has been tampered with. And so this EGNOS and Galileo help to track the origin of product and the supply chain. So this is the application of geotagging photos that we have piloted for the European Space Program Agency recently, so that the farmer can have in a self-service, doesn't have to wait for the inspector, but he can practically self-inspect his field and provide his report on correct subsidy use to the authority. There's no cost for the Galileo service and the EGNOS service, as long as you have the receiver installed on board. The high accuracy service will provide free of charge decimeter level precision, which is expected to further help the sector. agriculture becomes more and more data intensive, and you need more data for benefiting from the IT and the digitalization. You need systems like that. Providing high accuracy free of charge. So this was the agriculture part of it. So you can see how versatile the systems are, how they're being used. So you also can see here the listing of the people involved, authorities, associations, research organizations, startup entrepreneurs in this field. Also in agriculture, we're very well connected, and we're trying to have a pulse on what is happening in industry. Coming to the next area, emerging applications in the area of construction, geodesy, surveying, and so forth. So a wide array, in particular, where new infrastructure is being built, where it's being maintained, where mapping needs to happen on a highly accurate level. This is where most of the receivers are already Galileo or EGNOS enabled. A quick short video, I hope it's not as long as the other one, and more different landscapes of Europe. So you're going to get a free tour of Europe here at the same time. Utility companies are mapping the infrastructure using GNSS, from park benches to street signs to sewage networks. Systems are more efficient and more flexibly usable than ground systems. Improved positioning accuracy and integrity. So the accuracy effect in mapping, of course, explained here. All surveying grade receivers combine different GNSS for mapping infrastructure icons, provide accuracy, continuity, overcome the issues of multipath explained by Leica. Also, the key players, Trimble is a strong partner of Galileo, as you can see. Availability also in congested areas. Constant real-time positioning correction. In particular, in the Nordic regions, they are very much relying on Galileo-related capabilities for mapping, because Galileo is very good there. The cost-efficient tool as well. So we're taking you to Southern Europe. This was just Iceland. You're getting a real tour of Europe here. real-time solutions are increasingly important. More cost-effective, more efficient. I think we've had this one already before. So let's use the other capability, which is often overlooked. It's the timing capability of GNSS. Not sure if many of you are aware, but navigation systems, global navigation systems, are used to ensure correct timing synchronization for different infrastructure topics, in particular in the telecoms world, but also in energy and in finance. Stock exchanges, banks, fast transactions, they need to work on the same clocks, otherwise somebody feels cheated in a stock transaction. And in light of new regulation coming and 5G, fifth generation of mobile networks, more and more opportunities are there and more need for application of GNSS. If you have any more interest in the specific uses of these, Spacetech Partners has conducted 2 landmark studies for the European Space Program Agency with regards to the application in this area. And we'll gladly, if there's interest from Asia, we'll gladly share some of that through GNSS Asia in the coming months. Some more applications in the infrastructure arena. We need to save energy. We need to use clean energy. We need to only use energy when it makes sense. So increasingly, cities are changing their grids, are changing their activities using GNSS to optimize when and which lamppost to be activated so that energy is not wasted. Only if there is a motion happening or something, the light is being switched on, etc., etc. Garbage collection, yeah, optimizing the route for garbage collection using sensors. It's practically an IoT application, Internet of Things applications, where the garbage can is monitoring whether it needs to be emptied or not, and the truck needs to visit that garbage can or not, or it can wait for another week. A very interesting current topic for India is GNSS tolling. We understand there's an ambition to become tollbooth-free by 2022. Not sure if the deadline can be kept, but we have discussed this topic at length in our recent blog. Check out GNSS Asia and you get the latest and greatest of what we found with our local experts about the situation in this field in India. We're looking then, I think we've already had most of the security-related applications. Also, some of these ones we have had in our blog, looking at it, and I would assume that due to the geography, many of the emergency cases that we highlighted for Southeast Asia are also in the most populous country of South Asia equally applicable. Have a look at it, might give some inspiration for applications or coursework for your students. So now looking at what's touching us closer as consumers in an everyday life, using our smartphones in the sharing economy, in mobile applications, but also COVID mitigation. A number of apps have been built around the world to control COVID spread, to monitor where people are, to inform people about what's possible left, right, and center, what is possible where, etc., etc. Here in Europe, we have built solutions using Galileo to monitor which borders are busy, which border posts are even closed, to inform the trucking community in particular, if they have critical goods, that they get expedited, that they get a green lane to go across borders. That's what we have enabled in a very practical project very recently. So if you look at gaming industry, there's more and more GNSS applications using gamification. Pokemons might have had its height a few years ago, but still, those are things that make it very experienceable of what GNSS and navigation can do. And those things would not be possible without GNSS, those outdoor online games. Looking at mobility, certainly one of the biggest applications for GNSS. The main applications are fleet management, navigation, but also transport security and smart mobility. And we have also some technology. You see here an underground station, and you wonder how come that this works with GNSS? Well, there is a spin-off from European research that is using GNSS underground. A French company called Syntony has developed and patented this technology, which is already operational in Stockholm, been tested in Munich, and is operational in New York City. They're effectively building the capability that you can navigate inside a tunnel, inside an underground station, both for individuals, for passengers to know which exit to use at the one end or the other for navigating, or especially for security, people, safety, firefighters, emergency staff, if they have to go into the tunnel, that they can have navigation where they are. It could be dusty, it could be cloudy, it could be smoggy environment, so that they have a means of navigation underground. If you see an application for that, let us know. We'll gladly put you in touch with a company that has that technology. It's probably the last video of the suite. How are we doing on time, Anindya? How much more time do we have in the session?
We have got 15 minutes more.
Okay, so I think this is probably the last video, and we'll quickly run it, and then we will soon move into Q&A. So please stay tuned and get your questions ready. So you'll see all the buzzwords here of the mobility world and GNSS. Some more different landscapes of Europe. This is German motorways. Automated braking, assisted steering, all the autonomous drive applications. So you see here, Galileo is in touch with the chip makers, with the automotive manufacturers, with suppliers of the automotive industry. So the cooperative environment is enabled by Galileo and EGNOS. Share and use information is enabled through this. Reduce congestion, take the right decisions, where to drive, where to go, how to optimize your route. Galileo becoming even more important for the future autonomous age. You see here a speaker from TomTom, one of the leading navigation aids providers from around the world, a Netherlands-based company. STMicroelectronics is providing chips for the automotive industry, a French-Italian company. Accurate positioning is needed to make the many sensors work. You can see here one of the biggest suppliers of the automotive industry, Bosch, is working closely with Galileo on optimizing the system and optimizing the application for its own use in all brands of cars. So Mr. Trauter from Daimler, he is running a pilot project for Galileo here and now, implementing Galileo in sophisticated advanced truck solution. The gentleman you just saw is working very closely with Indian partners, in particular Elena Geosystems, in making it possible that the mining industry in northern India can use lone worker tracking applications. Sorry, repeating. So, container tracking, a few examples. A company called Traxens is providing attachment receivers to containers so that they can be tracked wherever they are, on the sea, on the truck, or on a railway wagon. We're seeing that also geofencing is used around factories in the just-in-time production of cars. Mind you, there's hardly any storage outside the car factories. The storage is on the road, so obviously they cannot clog the motorways around the factory, otherwise the workers would not be able to get there. So there is all kind of optimization using this automatic check-in in the vicinity, the geofencing around, in this case, the Audi plant in Ingolstadt. We've also looked at urban mobility in Asian markets. You can see in our innovation blog an article about China and how this GNSS is enabling urban mobility in China with scooters, bikes, etc., etc. In drones, we have seen some examples. GNSS enables beyond line of sight operations, safer operations, and also in the interest of the people under the drone that you don't get hit by a drone from the top. We're seeing drones being used in the fight against parasites. We're seeing urban air mobility applications, super drones being developed. Here an example, an article from Korea. And yeah, just now we're moving into the outlook area of my presentation of what's happening next. So very soon you're going to see in a summary the Open Service NMA message authentication. You're going to see the high accuracy service. You will soon hear about the novelties of the new Galileo satellites. It will still take a few years until they're up in the sky and gradually replacing the older ones as they become to the end of their life. We will introduce electric propulsion, inter-satellite links between the satellites to reduce the dependency on ground stations. There will be better antennas, better clocks, and we're not saying how it's done, but better anti-jamming and anti-spoofing systems built into the system. So stay tuned, and we'll take it from there. Now, what are the opportunities to engage for yourself, for your students, for your researchers? There are a number of competitions out there. Some of them allow participation of non-European participants, like an innovation competition. If one of the participants is based in Europe, typically also an Indian team can participate. Looking at also the GNSS world is a job market. Yeah? As I said before, we have just hired our first Indian into our business. We know of several Indians who have been educated at technical university here in Munich or at the University of the Federal Armed Forces, who are now working in the Munich-based GNSS industry. So it's an opportunity for your engineers to get an overseas stint, to learn about it. We need engineering talent. I understand India is producing many of them, and you are their educators. So if you need tools, there's all kind of online tools. There's all kind of information about advanced career options, about master studies in Europe in cooperation with European universities. let us know if you need any help in that direction. We're looking forward to broaden the engineering pool for GNSS, for Europe, but also for Europe in the world, because I think also the application companies in the world need GNSS engineers to put these applications into practice to the benefit of your society. I'm not putting it this one now. So, in the interest of having a few minutes left for Q&A, just a quick view of what you're going to see from GNSS Asia in the next few months. We're working on a hackathon in ASEAN. We're going to have 3 or 4 ASEAN countries, and it's fully endorsed by ASEAN, the Association of Asian Countries. It will be a virtual hackathon happening from the 12th to the 14th of November. Maybe there is possibility to participate, have a look at the detail, but certainly we are looking forward to hopefully do another Galileo hackathon with India in the next year. Interest from universities and institutions is certainly welcome. The more, the merrier. We would love to build the largest Galileo hackathon ever in India next year. Maybe take India as your spokesperson. We would love to hear and present that idea to the European Commission, and I'm sure it will be positively followed. As you see, we're working with other countries in roundtables and workshops, just one of the next ones mentioned here. So how to stay connected with us? There's a community, the hub at GNSS.Asia, where you can 24 hours, 7 days a week, get in touch, book meetings with people anywhere around the world who is registered. There's a marketplace you can put in your product, your service, your research request in there, see inspiring keynotes or recordings thereof. So it's the hub to connect Asia with Europe on GNSS. Also join on our website our distribution lists for various topics, being a startup, the innovation blogs, or just a newsletter of GNSS Asia. So now let's do the Q&A. Anindya, looking forward to your questions.
Okay, thank you very much. Thank you very much, Rainer, for your beautiful talk. First of all, number one, for a free guided tour over Europe, starting from Italy to the Northern Europe. Thank you very much. So, 2 things. Firstly, at the end of the day, we have got very good technology, everything, so on and so forth. But until and unless the technology is converted into real life application that changes the life of people, the technology doesn't have any meaning. And so at least what I feel. So in this presentation, I think, as already mentioned by one of very senior members, that you have presented excellent examples of how the technology has been converted into real life applications in different arenas of life. And I think that will give example to many of the researchers and faculty members here. They can take up the idea and start implementing the ideas for Indian perspective. And also you have shown the roadmap, that hand-holding, that how they can create collaboration with you as a partner through GNSS Asia or other academic institutions. So that's excellent. So I must tell 2 things. Number one, just now, just probably yesterday, I was going through a piece of news that the government of India, they are planning an electrical highway in between Delhi to Jaipur, some 200 kilometers, where instead of using diesels or petrols, it will be electricity would be used. You know, what are the causes? But once again, for this type of uses, one has to know the exact locations of the vehicles, what are plying in that route, so that the management can be well. So that is another interesting application may come up. And second point, very recently, our university, our group got some funding from the government of India, DST, for application of GNSS in the agriculture sector for smart agriculture. Anybody interested here, including the industries, we may handhold in implementation of the project, and I think I can seek help from Rainer and GNSS Asia. Very importantly, one of the very important factor here is how agriculture can be supported through space technology. That is very important for countries like India. Many examples Rainer has shown, and I can recall during the first Indian hackathon in Bangalore, many young participants from different engineering colleges, they have come up with ideas for how Galileo specifically and GNSS as a whole, they're being used for agricultural uses. So we have to take it forward. Now let me take the questions. First question is from Mr. Chandan Misra. Please explain about why primary and secondary chip used for Galileo constellation of signal E5A. I'm not very sure about the question. Please explain about why primary and secondary chips used for Galileo constellation of signal E5A.
Frankly, I can't answer this question. I was not the person deciding which frequencies are being used, let alone why the one frequency is used over the other. I suggest, Anindya, you formulate the question in writing, and we'll sure get an answer for you and for your audience. Yeah.
Sure. That I'll do. There are two questions from Ms. Dr. Chaya Verma. First question is, you mentioned about GNSS in power outage of grid failure. I repeat, you mentioned about GNSS in power outage of grid failure. Does that mean installing of GPS or Galileo or GNSS device in the electrical transmission line to locate the area of fault? If so, then will electrical hinder to get exact location? I think her questions, the first question can be placed in this way: that does electrical lines, that is the normal electrical transmission, that disrupts the operation of GNSS devices when it is used in case of power sector?
Well, I think the main application in energy sector is the grid synchronization, so that the various devices used to make sure the power is flowing in the right direction at the right voltage, etc., like that. That's the main application of it. I would assume in the inspection and in the routine and in the ad hoc inspection of power towers or cables or something like that, obviously using drones and other equipment, that's when GNSS comes to play. Structurally, there are GNSS devices that can be mounted on towers, on bridges, and so forth, and even the smallest irregular movement or sign that in a strong wind or something it's bending more can be potentially used to identify early before a mast is breaking. Yeah, I don't know, other than there is a big storm, that masts are breaking in our geographies, and I don't know about the rural infrastructure in India, but I would assume there might be, those are the applications that are being thought about.
Okay, thank you very much. I think another application of GNSS in case of power industry would be a generation of timing pulses, generation of timing, which I think would be taken care of in the next lecture after lunch by Dr. Banerjee. So Dr. Verma's next question is, regarding use of GNSS in locomotive tracking, can it be used as replacement of SCADA, or will it be used along with it?
SCADA.
SCADA, SCADA. I'm also not very sure.
I don't know the term. I mean, mind you, you have to look at the different levels of sophistication of locomotives. You have to look at, is it a dumb line that is just the rod of iron that you're traveling on, supported by wood or some other structure, or is it a railway line that has some kind of even just a simple power cable put underneath, yeah, that allows the use of balises and other things like that. And then you're looking at electric or diesel type of vehicle. So this whole combination gives a whole array of sophistication, what is possible, what is not possible. how much automation there is. Are there railway crossings? Are they automated? Are they not automated? Do they have gates? Do they not have gates? So there's not a single solution what fits it all for this. From the high-speed requirements are different from enabling with basic GNSS a warning that the train is approaching and people please get off the track, yeah? Which you might have in some parts of India. So I suggest to the person asking the question to look for the specific term SCADA, whatever it is, in the technology report of GNSS, because in that one there's surely that acronym explained and the context in which GNSS can help if it is. Yeah.
Okay. So, but Dr. Pharma has supplemented her question that SCADA means supervisory control and data acquisition for locomotive tracks control and monitoring. Okay. So I think it has been answered. Now, one comment from very senior member, Dr. V.K. Jain. Very good presentation with lots of advanced application for country. Very good videos. Thank you, sir. And next question is, please, if you want to comment.
No. I just with pleasure. Yes, thank you.
Okay. Next question is from Mr. Amit De. His question is: recently, Chinese researchers from University of Science and Technology teleported photon signal between ground and satellite. Is EU taking up similar projects related to satellite control quantum communication?
Yes. There are efforts, and we are aware. And I think even in some of the Chinese activities, some European technology from Austria is involved. The European Union, the EU Space Program, has launched several pilot initiatives called EuroQCI. Some of it is on the internet, to help shape a future communication system made by Europe. Europe sees it increasingly important to have more independence and have more secure systems for its own ambitions and for certain communication needs. And quantum communication is clearly one of those and one of the key enablers of that. Yes, there are several activities. For the person asking the question, check out the word EuroQCI and you might find some more information.
Thank you very much. So another comment from Dr. Subroto Pan. Thank you, sir, for such a nice presentation. And the last question, what we can Dr. Bharma has once again commented that thank you, very informative and inspiring session. Best wishes. And the last question, what we can take, already we have 5 minutes past time because once again we have to start at 2:45. From Dr. Kavita Gudad. In search and rescue system, should the person in trouble send the signal, beacon signal, continuously until rescue team reaches or only once? Does that signal contain location of person in trouble?
Yes, so the signal is continuous, to my understanding. And that's exactly the purpose, especially, and that's mostly the need when you are unintentionally floating about on the open sea. So first and foremost, you get the information that help is underway, the signal has been received. So hold your breath and make sure you keep exercise, that your body temperature doesn't deteriorate too much. And then obviously, when the helicopter is coming, it has a better chance of finding you because your position is dynamic. So that's a good feature about it. Whether that is broadcast through the same system or whether it's a more direct communication with the helicopter than using a special signal, I'm not sure of, but I'm sure it's explained in detail in the search and rescue explanation of the Galileo website.
Okay, thank you very much. A few more appreciations from Dr. Pramod Mishra and Dr. Jaideep Banerjee. Very much informative session. Very good informative session. So thank you very much, Rainer. And I would expect that some of the universities participating here, they will grab the opportunity of participating in the next Galileo Hackathon, which would be organized, which is being announced in due time. And definitely when the information reaches me, I will disseminate amongst you. And on behalf of all of us, on behalf of our university, myself, and all the participants here, I convey my sincere thanks and gratitude to Rainer. And obviously, the request is already there. Just please share the recording and PPT. The recording would be shared today evening once I upload the recording into YouTube, and it will be shared just like yesterday. And I would request Rainer to share the PPT so it can be shared with the participants. So thank you very much, Rainer. Thank you very much for providing us time. And please convey my thanks and gratitude to our friends in USPA, specifically Martin, who got you connected. Thank you very much.
Well, thank you. So it was a pleasure speaking to this in a so-called train the trainer session. I think you're ambassadors, you're multipliers of using high tech from space on the ground, inspiring youth, inspiring students, researchers to make it a better world. And I think that's all what we're doing here. Hope I can add something to it. And thanks a lot for organizing something like that. We would like to do it more often. Yeah? All the best. Greetings to India. Bye bye.
Okay, thank you very much. Thank you very much. And also, thanks has been provided by GNSS Lab to you. Okay, so we are closing this session right now, and once again we will meet at 2:45. So we have got